So here we are now, and before we continue creating the shell, we have to do a little bit of trim work. So I'm going to select those two shells and create the trim parts. And then I'm actually going to select this one and move it a notch forward, like this. Okay, good. And then we can go and start the trimming process, cutting out those parts we don't really need. And then at this point, we can create a surface blend or surface fillet. And I think I will need roughly like 1 or 2 millimeters. Let's put this on 2. And this shell is my first one, so I accept and make a fillet between those two shells. I have to set my vectors correctly, so they have to point outwards. Okay, let's press build, and yeah, let's say that is quite good. So there's now our camera filleted into the main shell. And let's zoom in here for a second. And you see that our shaded model has an issue. You see there are gaps here, as you can see, and that's a tessellation issue. Similar to the way how Blender works with polygons, you can see that the shaded mode in Alias is also polygon based. And now you might think, well, you know, I'm using NURBS, so that should be perfectly accurate. And that actually is true, but NURBS itself is just math and just a lot of lines. To shade it, Alias has to create a polygon mesh based on that input. Works actually similar to the way how, for example, the subdivision surface modifier in Blender works, where you have a low polygon cage and then a much more refined shaded mesh inside. So if we, for example, would create a polygon mesh based on those patches, we would end up with those gaps in here. And let me show you how this, for example, would look like. So I'm selecting all those objects. Then I go to File, Export, Export Active As, and hold on, let's make sure I have OBJ selected. Yes, I do. Save. And let's say shell alias obj. Hold on. I would like to tessellate it a little bit finer. So that makes the polygon mesh more refined. So I have more details. And let's go to Blender, File, Import OBJ, and there it is. The vectors are all correct. Import, and then I only have to scale it. Maybe let's move it onto a different layer so I can take a look at it. And there it is. So from a distance, that all looks pretty good. You don't really see significant difference, but if you zoom in, you notice that there is an issue. See, there are gaps and there are holes. And that happened because Alias took basically all those NURBS patches and for each created a polygon mesh. So I can, for example, put my mouse onto here, press L, which says select all the polygon points that are linked to that mesh, and you can see that those are all still individual meshes. Might be okay for rendering from a distance. So I mean, maybe from here you will be all fine, but if you zoom in for rendering, you clearly see that this is garbage. So what do we have to do here to do different? For prototyping, we need to create a so-called watertight shell. Watertight shell means that all edges are not naked. So for example, here, those thicker blue lines, those are the surface patch edges, and they have to be glued together to each other. And Alias has actually a very nice tool for that. In some programs, it's called join, for example, like in Rhino, and Alias is using stitch as the command, or how to name it. So we create a shell and we stitch, kind of like we're sewing all those pieces together. And all you can do is just click it, make a selection around all your shells you want to stitch together, click stitch, and then up here Alias will tell you that we created one shell with two boundaries. In general, you always want to have one shell if it's one object. If you have two shells, that basically means you have two objects. That's not ideal for printing at all, if it has to be a solid piece. And boundaries, that basically means there are naked edges or surface edges that have nothing to be glued or attached to. And you see those are the yellow ones. However, in our case, it's actually perfectly fine because we don't have a volume, we just have a flat surface. And later, when we create the wrapper prototyping mesh, we create the thickness for it. So how to create now the thickness? We can just say select nothing and maybe select object. I'm going to create a new layer, and this Maya shell I'm assigning to that layer. And yeah, I just create another layer as well, so you can clearly see the difference, what happens. So what I have here is my original alias mesh or the surface, and here on this layer I have my stitched surfaces. So the stitch command actually creates a duplicate object. So you're not messing with your original input surfaces, you just end up with a new duplicate part, which then we can select and safely mess with it without destroying our initial design. And then to create the wrapper prototyping shell, we can go to File, Export, and then go to Wrapper Prototype. And that's actually a really nice feature inside Alias. So we can select the shell, we use STL tolerance. That basically defines, for example, to what tolerance the polygon mesh should fit our NURB surface. So if I click accept, there we see now this is our NURB surface. If maybe I set this one 2.5 and click update, or maybe let's say 1 and update, or maybe 0.1 to go back, you see that at specific areas the mesh will get coarser or finer. You see now this is less refined, so my tolerance is higher. If I maybe set it to 0.01, click update, you see the mesh is a lot finer. So in this case, it will capture the fine nuances and blends of your surface better than, for example, having a tolerance that is too high. And to create now the thickness, you can click on create wall thickness. 2 in my case are 2 millimeters. And then with the flip normal, you can create that surface inside or outside. Maybe 1 millimeter will be actually sufficient. Maybe I would like this to be a little bit finer. So, and then this is basically now the computer model. And then you can click on export. I'm going to my desktop and say, no, this is my shell alias STL. Click save. And let's go back to Blender and go import STL. Here is that computer model. And STL stands for, as I mentioned before, stereolithography. So it is just another polygon mesh model. And you see that for Blender, for example, it is too big. But for the Wrapper Prototyper, it's perfectly fine. And I have to scale it down by actually scale 0.001, then it will fit, and I have to rotate it along the z-axis one time, 90 degrees. So this is now my polygon model. If I go into edit mode, you will see that, for example, here I do not have any naked edges. Everything is stitched together. So this object, for example, is or can be considered watertight. If I type shade smooth and maybe add an edge split modifier to sharpen sharp edges, then I can, for example, shade this nicely and use actually the STL export as the mesh for doing my renderings. But the same mesh now is also ready to be sent to the Wrapper Prototyper. And all you need to do is simply, where's the file? Here, this one. This shell STL file can just be sent to the Wrapper Prototyper, and then there, if it needs to be scaled up or down, if you want to make a quarter scale model or something, you can easily, or the person who's doing the printing machine can easily scale it down by that factor and then hit print, and it will create that shelf for you. So as you can see, it's really not a big deal to create this shell model and then create your mesh model. And in the following small minute, I would like to show you also maybe a small trick to check if your shell is okay. Because never trust Alias or any other NURBS program. Sometimes with polygon meshes, they are not necessarily always the greatest when it comes to export. So I open my shell and actually, cool. Everything is fine in this computer model. I don't see any bad part. This NetFab Studio, if you Google it, you can find the basic version for free online, and all it can do is open like a computer model and then see if there are multiple parts, if there are issues with the geometry, if there are holes. For example, Rhino has a very bad polygon mesher, so very often you have to repair those parts afterwards. And if you have this issue, you could click on repair, and then it will, for example, tell you here if there are edges that are naked or if your holes, and you could go automatic repair, click execute, click apply repair, remove all part, and then it's all fused together, and then you could just go to project, save as, sorry, that was not save as, it was export part, sorry, as STL, and then resave it. So not very difficult. I hope this answered actually all your questions about how to use the Rapper Prototyper machine. And I hope you noticed that it's really not something that is complicated. One tip, however, if you want to print something, try to always, and that is the most important lesson, always make sure your alias model you build in a good way, don't have surface kinks or bad geometry inside your NURBS model, because that will always be continued inside your polygon mesh export and will give you a lot of headache afterwards. So as long as you really try to work clean in Alias or Blender, then your rapid prototyping mesh will reflect that and you won't have any issue with it.